All right, two-parter today. We're going to talk about SQL injection, which some of you are already playing around with on the websites, and hacking SQL database servers, which your Metasploitable box has one available. Your Metasploitable 3 box. Back it up. We got a lot to get through today. Servers. Oracle is a brand name of database server. How worms work in databases. We don't run across too many of them. SQL injection is a biggie. It is sort of one of the oldest sort of web vulnerabilities on the internet, yet continues to crop up, so that's a problem. And then we'll work our way through what the techniques are, how that works in Oracle, how that works in MySQL, which is owned by Oracle, I think. And then Microsoft SQL, tools that will do the heavy lifting for you and automate things for you. The difference between SQL injection, where you can see the results of what you're doing, and blind SQL injection, which is a different thing, and then how you as a developer can protect your applications from this sort of nonsense, these sort of shenanigans, which we don't want. Most of the websites you go to, this is probably true these days, are basically front ends for databases. Does anybody go to websites anymore? Do you guys do that? I mean, like, let me click on Internet Explorer so I can visit my homepage and see what's going on Yahoo. No, me neither. What winds you up on a webpage these days?
Informative content.
Informative content. Rosema assigned me chapter 3, so I had to go log in. But for fun, for when you're on the internet's for funsies, what gets you there?
Usually just like
Furries for Dave.
sick video stuff. Like everything I would use the internet for is mostly on my phone.
So now you're on your phone, now you're looking for videos, so you wind up on the YouTubes a lot, or?
Yeah, YouTube, Twitch, Silly. Everything else would be like can't go through applications already. So like, if you're trying to deal with World of Warcraft or Battle.net, you just use the Battle.net application.
Right. Nobody uses the FaceBase or the MySpace or the LinkedIn's or the Tweeters.
Does MySpace have an app?
Good question. I don't think so. But all those things, those social networks I just mentioned, those are all just huge databases with the front end. Twitch, YouTube, big database driving the web and the mobile app. They have to have it, right? Big app.
I guess.
News? Have you guys heard that? Apparently not. I saw the last election. I kid you.
Most of the news on the internet is junk anyway.
Is that true?
A good chunk.
It depends on where you're looking would be my statement. One of the things we really need to get a handle on is like teaching students the ability to discern, to get the BS meters up. Like we went through this in Ethical Hacking 1. We talked about Carl Sagan and like being able to detect BS when you see it. I feel like if you get a handle on that, then you'll be able to tell the difference between some Macedonian kid's website talking about how the Pope is endorsing Trump and like the New York Times. It's hard. But all those things are databases. And those are fun to attack because you don't really have a lot of other options. If you're attacking a website, you're probably attacking a database. Databases that don't face the internet can be particularly valuable. So things that have credit card numbers, personally identifiable information, healthcare records, that sort of thing. Passwords for users, but they'll be hashed and salted and encrypted to a point where you can't read them. And the way people tend to get in is through some poorly sanitized input that the user can do and SQL injection. So, sounded like with our little straw poll of the class that everybody had to deal with SQL at some point. Structured query language, been around since before I have been. But a text-based interface to a database server that has a really kind of wonky old school syntax. It does a lot of like, if you ever typed COBOL for, which I don't know if you ever did, kind of the same idea that it was like, we'll make this more natural languagey and it'll be more intuitive to the user. But SQL injection is when we see something going on a website, say to ourselves, that looks like it's just taking whatever input winds up in the bar. And we know that if you're not doing a great job of stripping out all the extra stuff from what a user puts into a web page, that gets taken, handed off to the the database server, and the database server does the thing. Database servers are computers, so you can actually have them do a lot of things, which is nice if that's what you're trying to do. So hopefully, if you do a scan of a host on the internet, you will not discover that there is an Oracle database server open on port whatever. Man, I hope not. Although I guess recently there was back in the olden days, one of the things that really got us fired up about internet security at my last job, to kind of date myself, was this SQL slammer worm that found its way across the internet like super fast, shockingly fast. Because what it did was, it would look for, not Oracle, we'll probably talk about this, it would look for open Microsoft server ports, exploit the server, and then it would start looking for other open Microsoft ports, exploit the server, and that happened so fast that like inside of minutes, it felt like it was hours. The whole internet was compromised. And if you had a web server facing the internet, which is super bad practice, and not a good thing to do, you were owned just like that. So if we could find a SQL database pointed at the internet, somebody has done it wrong. They're already off to a bad start. So you probably won't have any problems finding an SQL injection vulnerability. So if somebody doesn't validate input, that's important. So if there's some place where we don't, the programmer asks for a username field, user hits submit, and that whatever was put into that field gets handed off to the database server. That's non-validated input. We didn't go through and say, did somebody try and sneak some SQL commands in there? Because if they did, and we don't strip it out, the database server will execute whatever you sent there as itself. So when you have a database, that database has users. One of those users is probably the web application. And now if you can sneak input into it, if you can inject code, or if you can ask for a table, the result of a table, like give me all the usernames and password hashes. It's often a useful one. Then they're in trouble. Additionally, if there happens to be a place where you can force a buffer overflow, that's going to be harder to find, but it's conceivable. These things can be used to escalate, to get you into trouble. So you can wind up with a web user having more privilege than they should. Maybe you made assumptions when you built the web application that were there to restrict the things that the web app could do, and you can bypass that with SQL injection. That is abusing privilege. You could be doubly unlucky, and the platform itself could have vulnerabilities. People can knock your web servers offline, and people can subsequently knock your SQL servers offline, especially if they're public-facing, especially since, remember, bad idea to do that. Sometimes there are vulnerabilities in the protocols, and frequently this is a good, like, generic web application hacking sort of attack. Sometimes people will do foolish things like leave their backups web accessible. Sometimes they're doing that on purpose, thinking, wouldn't it be nice to be able to download this backup so I could have a copy of it at home? And sometimes it's just like, I tarred up the HTML directory and I let that tarball sitting in the root of the web server, which seems like a good idea at the time, not so much. So imagine you're a fledgling Oracle DBA. You sit down to create a database. You install a user called Outlins. And then you forget to go through and change that password. You don't bother to mess with the DBA account, the default administrative account. So imagine if you built a new Linux box, and you didn't change the root password, or you set up a Microsoft server and you left the administrator account blank. That's bad. And so same thing happens in database land. If you have a user like Outland, and they are privileged to execute any procedure, bad things happen. So if we can somehow use SQL injection to inject code into a field, so please enter your username, and they don't bother to check it. Now we can push through SQL commands that talk to our database. And depending on what our architecture is for that web application, it might be JSP, it might be ASP if you really hate yourself. It might be Perl, might be PHP, might be whatever. It might be Bash scripts. We see that we can do that, and then we can start building onto it. We can start playing around with those queries. So if you're building a web application, this is what should not be there. Nobody should be able to see login, search, feedback pages that talk to a database that don't get sanitized. If you're ever entering something into a website and you hit submit, and you notice that after you hit submit, the URL bar now says something like username, question mark, my username, question mark, password, question mark, my password. Bad things are going on. Those post and get methods to submit database info can be scary, not good. So here, badstore.net asks you for your username and password. And if you were curious, you might throw in a single quote at the end of that, which if you think back to your SQL is probably how you would terminate a command like insert into users, single quote, my username, close quote. So if I put my username, close quote, comma, or semicolon, delete all tables, that could get ugly for whoever's on the other side of that database. And that's kind of SQL injection in a nutshell. Sounds super simple. I can explain it to you in 2 minutes. I don't know if I can get web application developers to take it seriously. Most of them do. I hope. Pretty bad. So, like we footprinted an organization, like we footprinted a server, you can footprint a database and kind of try and figure out what database it is you are dealing with. If you did something silly like left it exposed to the internet where I can connect directly to that port, I've got all kinds of tools out there that'll help me figure out, and that will tell me, oh, this looks like a SQL server running on port 123 or whatever, which is great. So remember, this isn't attacking Apache or Linux or Windows or whatever. We're attacking the application itself, which is sort of different. If there's a HTML page that uses a post command to submit something to an active server page, a Perl script, a PHP script, a CGI script, or whatever, we're getting in trouble. These guys love Olay, Microsoft's object linking and embedding stuff, but this applies to just about anything. So if you see something like index ASP question mark ID equals 10, we might just be able to throw SQL after that and see what happens. So in this case, union select top one table underscore name from information underscore schema.tables. They'll be asking, hey, tell me about the tables in the database schema. That works. Oh, good. Sometimes you can learn about the database server based on the errors it throws back at you. So here we send this query, select blah, 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 to a table, name equals admin underscore login. And instead of getting nothing, which is what you want your web application to give back to somebody who's trying to hack it, if you are being helpful and throwing error messages, which is nice to know, it tells you that, oh, you're trying to convert a character value to an integer value, and you can't do that. So next time you try to hack me, please make sure when you fill out this field, you use an integer as opposed to trying to send characters my way. Oh, well, now I've learned something about your database, and that's bad. Again, same deal. Here Microsoft is telling me back that I'm trying to put a name into a number field, feeding me more information about the database. So I've learned something there. If I can, I just throw valid SQL at it and change the password for your website. So if I can do this, your website's going to have problems. If I can go in and update admin and set the password to newboy5, because reasons, I guess, or add a new record, create a username we've kind of figured out that the login is a number and the name is a text value because of those errors it conveniently gave us. And the password is a plain text, non-encrypted password, which kind of makes us cry a little bit on the inside. And then details is some field that we're just not going to fill out. We can send all that stuff in, and now we've created a record in the database, which as far as the web application is concerned, is the username and password, the login for, what do we call ourselves, URI2? So you're like, I am going to be a good developer today. I'm going to make sure that I validate my input. This will protect me. But that can also kind of get you into trouble too. So if you use validation code, again, if you trust user input, which is a mistake, to build the SQL statement, so you're like, you know what, I am not going to directly take user input. I'm going to validate it, and then I'm going to put it into a user input statement. And I'll tell you what I'm going to do. I'm going to take any quotes, and I'm going to turn them into something else. You can go ahead and cheat that, because I'm tight. I'm glad I've given it back to him. Mm-hmm. I'm going to cheat it, and I'm going to force my own code into their input validation. We have a student who will be joining you guys for the ethical.
Maybe.
Oh, we're out of 3 minutes.
Yeah, he's done.
Dang, I'll get you some more. We have a student who will be joining you for the system defense competition, who found one of these authorization violation bugs. I thought you said you were done.
Okay.
All right. You can keep this up here. Excuse yourself. Go have nose replacement surgery. So he found one of these bugs in a government benefit webpage where he noticed that his username was up in the top of the URL bar, swapped it out for another guest username, because there's a J. Smith everywhere, and saw somebody else's government benefit document. Submitted it, they fixed it, and now he puts that on his LinkedIn profile. So that's a problem. Nice for you to keep an eye out for it. We should build into this class like a section on responsible disclosure. But he disclosed it responsibly. He let the vendor know before he went and put it on his LinkedIn profile. Before he typed up a blog post about how it's easy to pwn, whatever department it was. Feel free to ask me about it sometime Saturday. So if I can evade the login form altogether, so if your web app was written in such a way that it assumes that if you got to, shoppingcart.php, the only possible way a user could ever get to shoppingcart.php was if they got past login PHP, right? It's the only way. Well, if it turns out you go to shoppingcart.php and put in the variables, you get a valid shopping cart. Now I've evaded your login form, and I'm up to no good. Depending on how that goes down, you might use select commands to do it, and select rows and columns from the database and learn about all the different fine products you have in your database, or all the social security numbers of all the patients in the database, or whatever. And then, this is sort of SQL 101, but insert, usually used for adding someone, like adding a new user, or adding a blog post, or adding payment to be made, could be scary. Oh, it looks like we have to send a $50 check to drew.rosema@gmail. Well, I guess we better send him the check. In SQL, there's this thing called a stored procedure. So a procedure is like, do this, do this, do this, and do this. It's a code reuse tool. Depending on how the web server is set up, you may have access to the default procedures. Wouldn't that be nice? One of the default procedures that Microsoft leaves laying around is command shell. Uh-oh. Command shell lets you run commands, as if you had like clicked start and run and typed it in the little run bar. And if you can pull off something like this, command exe dir c:, you're not very far from using that technique to launch PowerShell script to open up a back door, to start netcat so you can have remote shell access, to doing all kinds of naughtiness. It's no good. Any of these things, once you've got access to executing code on the server, you're real close to game over. From there, it's just a privilege escalation vulnerability away from really rooting the thing. So any of these things are possible. Maybe once you can execute some kind of procedure, now you are acting on that server as if you were the database user account. So you could ping things, you could list all files, you could create a file, like a file that was one of the vulnerabilities in this example application is you can use it to create a PHP shell script. A PHP shell script that will let you execute whatever you want. If you were lazy and under the age of 18, you could deface the website. Or if you really had a political message you wanted to say. Any of the non-GUI stuff, maybe some of the GUI stuff. Nothing more fun to mess with an administrator than by having like calc exe pop up in the middle of your server. And then you come into work that day and you're like, why is there a calculator in the middle of our web server? Probably a bad idea. More commonly, these bad things happen. We upload a Trojan or some kind of backdoor to maintain access to the system. Or if you're Sony, somebody starts downloading all of the scripts for next year's big blockbuster movies. So those are bad. Another little history lesson here, Voyager Beta would go through, grab IP addresses, and try and establish connections. Same kind of disaster we wound up with Slammer. Creates a table if it gets in, writes down the IP addresses, keeps on keeping on. So single quotes to your friends if you're looking for these sorts of vulnerabilities. That Attack Sam site will let you try this out. If you see anything like this, index ASP question mark something, get suspicious. And then throw in a little SQL at the end and see what happens. If you're authorized, you're participating in a bug bounty, if you're working on a lab, you start doing that when you're browsing the Department of Defense websites, you might get yourself a visit from the Secret Service. So be careful out there, kids. So what's gone on there? If I threw a string in there, the query string existed in code somewhere. Right? So somewhere my PHP or ASP or whatever calls query string, which we let the user manipulate. And the user threw this into our query and changed count from where username blah blah and password blah blah and turned it into where username equals blah blah or 1 equals 1. When does 1 equal 1? Forever. Until the universe gets weird. In which case, I'm out of here. So it will select from that, the author of the code assumed this was going to be a test. It was going to test to see that the password equaled the password that was given on the website. Now what's happening is from username, or if 1 equals 1, which it does, do your thing. So it does its thing. And then you can start adding your SQL afterwards to do whatever it is you want. Sometimes you have to get tricky with your SQL. So in Oracle, put a union statement in there. So you get a second statement executed. So finish doing whatever it is you're doing, union, whatever. You can also, in Oracle, you can do sub-select. You do select users from username or whatever, or select username from user or something like that. You can then sub-select underneath it. You can start looking at what we call the data definition language, which is just the data about the data on a database server. And then the easy ones, insert or update. So inserts to create a new record. So add user, Drew, password, I pwned you. Or update user administrator, password equals I pwned you. Or if you really want to mess with it, delete user administrator from the record. That doesn't do you any good though now. Now you've just broken the web application. You can also throw things into your own procedures if you've got that kind of access. All sorts of fun. MySQL tries to be better about this. So being sort of born of the internet, they thought about these things while they were using it. So no errors on unions. So if you're trying to throw SQL statements with union commands in there, it's not going to tell you what you screwed up. Single quotes in queries can be escaped out to escape single quotes, which is a good idea. But if you've got that input validation, it's still possible. And if you've got a script that's manipulating MySQL, the nice developers of the database can't be held responsible for what you did when you wrote, superlead bash script .cgi. So the server itself, this is a thing you can do to your Metasploitable free routes. If it's directly connected to the internet, the battle's half won. They have failed. Your SQL database has no business being on the internet. If you have a web server that needs to talk to a database, that forward-facing web server should be out here, and there should be a big fat firewall between it and the database. And the only communication you should let happen is just that database talk. So web browser should be out here talking to the web server. Web server talks to the database. And there's a nice firewall preventing anybody from talking directly to that database. That's not the case. Naughty. Bad systems administration. Bad DevOps. No biscuit. Vulnerability scanning. If you find a SQL server sitting on the internet, maybe somebody's already done the work and there's a 0 day out there for it. Probably. Obviously, this person doesn't know what they're doing. You can see if it does SQL resolution. SA is another name for root. Systems administrator. Sometimes there's attacks. Maybe you can have a SQL injection. A SQL injection that doesn't return error messages or results is sometimes called a blind SQL attack. Those can be difficult to find because you have to use what's the word I'm looking for? A side channel information to figure out that there's a SQL server back there. And the way you figure that out is if the response time when I click submit is longer to give me an error message that's a generic error message, maybe there's a SQL server back there that's doing something. And then you can try playing with it. If you're looking at a system that's well known, like a WordPress or a Drupal site or something like that, you may be in a position where you can reverse engineer it pretty easily. If you can get an image of the system and look at the code, that makes reverse engineering really easy. But if you can't, if you suss out that you're looking at a Drupal site because it's got the little blue circly guy as the icon or whatever, then you can look at the code for whatever version of Drupal they're on and see if you can figure it out that way. There's plenty of Google hacks, which everybody should have looked up at least once, that you can use to. Google's already done the work of indexing most web pages for you, so you can use their tools to take a look at it. And again, if the code's out there, have a read. Take a look. Web Inspect is a tool-time tool that will go through and figure these things out for you. I've heard that, no stapling your fingers, please. I've heard that there are more and more security products are being integrated right into the development environments for these things. So before a developer hits compile, they can hit check for vulnerabilities, and these sorts of things come in handy. Anybody ever seen this thing before? There's apparently a cow or something. But Metasploitable has all sorts of SQL Server vulnerability binders for you. There's a big old list. If you want, bust out your own C++. Write it yourself. So, you want to hunt down a Microsoft SQL Server, it's kind of like kicking a puppy, but if you find one out on the internet, it probably has this coming. Of course, you would never do that. Because you will never do that because somebody's probably beaten to it, and the server's already offline. But you should be able to, if you find one out there, you will be able to learn what it does. If you can connect, you can do SQL-L and a list of things. There are tools for sweeping and port scanning, and there are commercial alternatives out there you can buy that will do this sort of thing for you. Server resolution service does the communication process for you. OSQL-L is their command line tool that looks for installations of SQL Server on the network. You can see how this turns into a SQL Slammer real fast. And then Server Controller will go through and look at computers, and if they're offering SQL Server services, say that 5 times fast, it'll let you know. And then there's more, all kinds of automated SQL injection tools. These are the kind of things that set off intrusion detection systems. SQL map's one worth looking at. But if you start firing these things off and they have any kind of intrusion detection on their web server or a web application firewall or something like that, when 160,000 SQL queries get fired at the server all in the span of an hour, there's going to be a very big bar on somebody's web analysis dashboard. Right? They're going to say, man, I can't believe we had this much traffic this month. What's going on? So blind SQL injection is when we get client data and execute it. It doesn't validate the input, but it doesn't return info to us. So that's bad. You can prevent it if you never let people modify your SQL statements, which is nice. Sometimes they recommend that you build them into procedures that aren't changeable. Keep your web app away from SQL. Sometimes easier said than done. If you can, store SQLs and procedures on the database server, which probably shouldn't be the same physical machine as the web server, if at all possible. You should have a safe interface for those stored procedures. If you've got to use something, Java has a prepared statement object you can use to keep you safe from this sort of thing. Stored procedures are pre-built before user input is added. So if you get tricky with your commas and your semicolons and your quotes, our pre-built procedures should ignore them. If you can, who paid attention in Linux 2 when we talked about SQL or regular expressions? If you can, build regular expressions to take this sort of stuff out, to help you with your input validation. So every time somebody types something into your web service, check it. And keep an eye out for single quotes and double dashes and semicolons and the kind of things that show up in SQL statements. And turn them into something else, something harmless. You can go through and look for all single and double quotes, convert them over. Minimize privileges is like good advice for everything forever. So your database server user, so you've got your database server running behind the firewall, because you listened when Professor Rosemont was talking about how to build your web app. If SQL injection creeps in, it will be executed in the context of the database user. So if the database user has access to the root of the file system, bad. But if the database user can edit the database a little bit, but not everything, can only add users, can't change passwords, can only do the very restricted things that you want it to do, excellent. So that's minimizing privileges. If you have a shop where you've got real honest-to-goodness coders, you can all implement consistent coding practices, and everything will look pretty much the same the whole time. So if I write the code, the joke in programming is that you need to be twice as smart as the programmer who wrote the code to debug the code. So always write your code at like half of your total cleverness level. So if you are a level 18 or an IQ or a int 18 code wizard, always write your code as if you were an int 9 code wizard, so that you'll be able to debug your own stuff. Few people can, but if we have consistent coding practices, and I know Elliot's a lot smarter than I am when it comes to this code stuff, I can say, Elliot, you double check this stuff. I adhered to our consistent coding practices and procedures. I'm not sure I've escaped all the quotes quite properly.
I feel like objectifying code is making it very easy to use though.
Like making objects into it, and everything's a function now, and we just call a function instead of having to write something. Okay.
So everything comes with instructions now.
Oh, and I, you know what, I am all for that. The further you get me from the compiler, and from the kernel, and from the processor, the better off the world is, you know. If I can, I'm pretty good with Legos. So like if I can take your red block and your green block and kind of stack them together to get it to do what I want it to do, then perfect. If I've got to start over melting down candles to turn them into plastic stuff to make Lego blocks, it's gonna go bad. So totally. Problem is, like with, this is where like the bloom came off the rose of open source software with me. When the SQL vulnerabilities that had been around for 20 years showed up a couple of years ago, and when the Heartbleed vulnerability inside of Apache came out, and that had been sitting around for a long time before anybody noticed it, kind of realized that some of those Legos you're building with, the ones that are way down at the bottom of the stack are really kind of rotted out and old and nasty, and nobody's looked at them for a long time. Man, I'm belaboring the crap out of that metaphor. Let's move on. Here's a bunch of crap you can look at. Tools abound. App Radar, DB Encrypt. Wouldn't that be nice if your database was even encrypted? App Detective will go in and scan and pen test and security audit your tools. Oracle's got an audit tool you can use. You can go down a nice administrative checklist. Totally a big believer in checklists. They've been keeping us alive on airplanes since there have been airplanes. So if it's good enough for a pilot, it's good enough for everybody else. Read the checklist manifesto by Atawe. I don't want to slaughter his last name, but he's an Indian doctor who is a surgeon. And they did a study where just by having checklists in surgical units, the number of people who live skyrockets. You're never too smart for a checklist. You know, make sure you can check the physical security box, firewall box. At least one firewall between your server and the internet. Probably another one between, so firewall, web server, firewall, database server is not overly paranoid. That's perfectly acceptable. Separate services on separate computers. So if somebody compromises the web server, they haven't necessarily compromised the database server. They've got more work to do. Service accounts should be created. Windows and everything else should be created with the least privilege allowed. If possible, use a file system that has permissions built into it. NTFS does this. X3, all of X4, all of the fancy Linux ones do. Make sure that that database user can't get out. So understand that he is a potential vulnerability, or should your database user, and jail them with permissions. Developers should be checking ownership. They should be. This is why I love Python, because like simplicity is implicit in its intent. There's a lot of words. So it's designed to be simple on purpose so that we can read it easy. Code be simple, reading easy. Developers happy. Security guy, copacetic. Turn on encryption is good. Don't tell people when there's a problem. Specifically not what problem. It's okay to say, something went wrong. And like the smarter web service companies out there, if you've ever developed, gone to a wrong page or something, the 404 error you get should be the same no matter what. And your web server will do that for you. When testing these kind of things, it's not uncommon for a developer to turn on debug messages. Those are great when you're writing the code, so you can figure out how many extra single quotes you left in that were screwing things up. But they are not great for if I'm out there trying to hack your web application. That's bad. You don't want And if you can, if at all possible, we've talked a couple of times about that here's your web server, and here's your firewall, and here's your SQL server. If at all possible, before it even leaves the web application, before it jumps over that firewall, you should have validated that input. Your web application should have used one of the libraries that are out there to check input. And if it looks bad, you didn't let it pass through. I like to think of this as like good advice for life. Never trust what somebody told you, including me. Google me up online too, you'll find out. Letting SQL be generated on the fly by your web application, usually dicey. Best to have procedures stored that you call on. Dear God, don't connect to anything with an administrator level account. If you leave your Kali Linux box on the internet, build a user, log in as that user, escalate on the box, don't. Secrets, passwords, and such, not plain text, should be hashed, ideally should be hashed and then salted, so that you're not vulnerable to rainbow tables and pre-computation attacks, as they're sometimes called. If you have to throw an exception of some sort, you don't really, but if you do, don't tell us your password for database, critical user database, was incorrect, but your username is right. That's no problem. And there are tools to do this. Acuinetics was the one that hacked the regional vote. What was it? The regional, with the Secretary of State websites. Before the election, there was a bunch of database dumps of voter registrations, and we know that Acuinetics was the tool they used to do it because they didn't bother to change the HTTP agent field. So when it connected to the website, it said, it could say like Firefox or Chrome or whatever. Well, it said Acuinetics Web Vulnerability Scanner. So, which might have just been like a really clever marketing ploy for Acuinetics, now that I think about it. Our Web Vulnerability Scanner is so good, people don't even need to worry about it. So worth investigating. So databases are the internet these days, pretty much. And if they break, bad things happen. If your target in your database breaks and gives out all those credit card numbers you've been hanging on to for no good reason, that's it. Web developers make some mistakes. We're all human. We should try and fight against that. If I can hack your database through my web browser or through my web interface, is probably more accurate. Because using a tool like Burp Suite or a direct SQL attack is usually a better way to do that. If I can find your Oracle database or your MySQL database or your Microsoft SQL database server through a port scan on the internet, you're doing it wrong. And if I find it because I'm already behind your firewall, well, you got bigger problems probably. PL SQL injection can get me from low-level privilege into something with database administrator privileges. Those are bad. If you're not validating input, call me and I'll validate it for you. And I'll smack your wrist and tell you, naughty programmer. Too much privilege is a bad thing in almost every situation. Don't let people get into sensitive data. Use a query analyzer, use Acuinetics, use some tool to scan your own code if at all possible. Remember that a blind SQL injection attack can be in a web app, can be in the back end during a vulnerability scan or whatever, but just means I can't see what happens, which is actually good. It means you've done at least part of it right as a developer. There's database management tools that let you have easy access. There are tools out there that will look into your application calls from the Windows API. There's App Detective for web application scanning. Usually when they throw these into the slides, it's because you might find them on the test if you sit for the Epic Hacking exam. SQL injection slips through the firewall, uses your crappily configured web application to get into your probably equally crappily configured web database. It's not good. And lets me mess with the SQL. Messing with MySQL is bad. Mine personally and MySQL, the database server, is bad. Don't do it over on the internet. Footprinting is when we map things. Sometimes exploits happen, and when they do, it's usually I didn't validate the input or I didn't code right. And then preventing that is doing good coding practice, good database administration, good systems administration. I would add to that. So make sure your database administrators are doing it right, least privilege, patches, all that jazz. Your coders are doing it right, least privilege. good practices, and your administrators are doing it right, up-to-date patches on the operating systems, firewalls in place, systems in place, all that kind of stuff. And we do all that, and we'll have happy, safe SQL environments for years to come.